Hello everyone, this video is about PW127 series engine and propeller rigging installed on ATR 42 and 72 applications. It is a collaboration work between Pratt & Whitney Canada and ATR. The video provided here is for training purpose only. Always use the approved and current ATR or Pratt & Whitney Canada maintenance manual when performing maintenance.
Hello everyone, my name is Jan from ATR.
My name is Chandra from Pratt & Whitney. In this video, we will show you how to perform rigging on the power lever to the MFCU, also on the propeller transfer tube adjustment. We will also use the example of a torque split and how to solve them by doing the rigging.
Reference. There are two topics for discussions here. For utter or complete adjustment of power control, we use reference from ATR maintenance manual as shown. Subtask B, DVI or power mechanical control, and subtask I, adjustment of micro switch unit, are omitted for clarity. For torque split troubleshooting, we use reference from ATR maintenance manual as shown. Warnings. Put the aircraft into maintenance configuration as per the AMM. This shall involve putting warning notices in certain location, access panels removal, and circuit breakers to deactivate. Read and understand all the warnings and safety procedures. When working at elevation, always use a safety harness for fall protection. Refer to local health and safety requirements. Table of content. We will split this video into two parts. Part 1 for utter power control adjustment and Part 2 for torque split troubleshooting. We will use the info that we will learn from Part 1 to work on Part 2. Alright, now we are on Part 1, utter power control adjustment. There are 4 main steps to do this. Step 1, MFCU and PVM push-pull rod adjustment. Step 2, cable tension check. Step 3, cockpit push-pull cable adjustment. Step 4, nacelle push-pull cable adjustment. Let's walk through this video together. To complete the task, you will need the rig pins and the turnbuckle tool. There are 4 types of the rig pins. One for power lever and condition lever, one for MFCU, and one for PVM. And the other one will be for the quadrants. For the turnbuckle tool, you could make it yourself if you want to. And the tips distance will be approximately 17.5 centimeters. Let's identify the basic stuffs, which will be discussed throughout this video. First, we have a push-pull cable. The movement is in push and pull direction. How to adjust it? By adjusting the rod end. Later, we will find out for nacelle push-pull cable, we have to adjust it differently. Then we have a cable. With the help of quadrants, cable will also move in push and pull direction. The cable adjustment is done by turnbuckle. The last would be a push-pull rod. It has the same push and pull movement, and the adjustment is done by the rod end. So, where are they located? In the cockpit, you have power lever connected to quadrant by a push-pull cable. At overhead ceiling, we have cables connecting cockpit quadrant with nacelle quadrant. This is a long cable run. The nacelle quadrant will connect with MFCU upper lever by the teleflex cable. This will provide you the illustration how power lever movement in the cockpit. We will then eventually move MFCU upper lever, then moving PVM input lever. We are now moving to access panels. What panels need to be removed to do our work? In the cockpit pedestal, there is access panel to remove for accessing power lever and condition lever push-pull cable. There is a rig pin hole for power lever and another rig pin hole for condition lever. If we just want to install the rig pins only, we don't need to remove the access panel. Another access panel would be at the cockpit entrance door. It is a floorboard. This is to access cockpit quadrant, the rig pin hole, the push-pull cable if adjustment is required. Then going backward from cockpit door, there is an access panel at the ceiling. This is to access cable for performing cable tension check or to access turnbuckles if we need to adjust the cable tension. There are two turnbuckles here. Moving from A-frame side to engine side, there is access panel at the nacelle as shown. This is to access nacelle quadrant, the rig pin, and the teleflex cable. This is over wing area. Wear a fall protection device here for your own safety. Last access panel to go would be the propeller hub area. This is to perform propeller transfer tube adjustment. We are done now with the access panel, so now let's discuss the rigging sequence. It is important that we understand this slide correctly. Repeat it if we have to. We split the rigging into two areas, engine side and A-frame side. They are connected by nacelle push-pull cable, also known as a teleflex cable. Start the rigging process on engine side at MFCU and PVM by adjusting the push-pull rod as required. This is step 1. Then move to the A-frame side, check or adjust the cable tension. Step 2. Then check or rig the cockpit push-pull cable, and this is step 3. Once the A-frame and engine side are correctly rigged, we will then adjust the teleflex cable, connecting A-frame side at nacelle quadrant with engine side at MFCU upper lever. This is final step, step 4, and we are done. So now let's observe how the power lever and the associated cable quadrant and the push-pull rods move.
Ground idle to fly idle. Fly idle to take off. Retarding, take off to fly idle. Fly idle to ground idle. Reverse, make reverse, spring loaded.
Alright, let's go into each 4 steps and how to get them done. Step number 1, MFCU and PVM rigging. Set power lever and condition lever push rods to predetermined length. Adjust power lever push rod. Adjust condition lever push rod. So let's observe how to do it.
In this video, I will show you how to control the adjustment of the power lever and condition lever rod in order to readjust it if it's necessary. So here I have the power lever rod, and I'm going to use this template that I prepared for this video. And now it's time to lock. The anti-rotation nut have to be done in the small groove, and I just need to tighten the nut to maintain position. Same on this side, same here, and also here and here. So both condition and power lever rod are correctly adjusted.
Once the push rods have been preset, let's do the final adjustment at MFCU and PVM. Install the rig pin at MFCU upper lever as shown. Install the rig pin at the PVM forward lever. Install the push rod at MFCU side first and show the orientation of the rod end and bull head. It is as shown. Now, with the check nuts loosened, rotate the rod body to align on the PVM side. Ensure the bull head and the rod end orientation on MFCU and PVM side as shown. Now, let's grab a lock wire, check the inspection hole to ensure sufficient threads are engaged in. For condition lever push rod, install the rig pin at MFCU and PVM as shown. Install the push-pull rod at the PVM side, then adjust the rod to align at the MFCU side. Check the inspection hole. Check the bolt and rod end orientation as shown. We have just completed step 1, so let's continue with step 2, cable tension check. Perform the cable tension reading by using the cable tensiometer. If adjustment needed, rotate the turnbuckles as required. Refer to ATR/AMM for cable tension required versus ambient temperature. Use the correct riser for the cable tensiometer for the cable size 332 inch. If cable tension adjustment is required, proceed to next step. We have two cable sets, cable set A and B, connecting cockpit quadrant to nacelle quadrant. The cable tension is adjusted by rotating the turnbuckle as follows. Set power lever at flight idle. Insert the rig pin at cockpit quadrant. Adjust the cable tension at turnbuckle A to get the correct tension. And check that you can insert rig pin easily at nacelle quadrant. Nacelle quadrant. Do the same for turnbuckle B. Cable tension adjustment, only if required. Remove the safety clip from one of the turnbuckles. There are two turnbuckles and we will do it one at a time. With power lever at flight idle, insert the rig pin at cockpit quadrant. Install the turnbuckle tool and rotate the turnbuckle as required to get the correct tension. After adjustment, check the rig pin can be inserted easily at the nacelle quadrant. Install the safety clip and do a pull check to ensure it is secured. Once this is done, do the same adjustment for the second turnbuckle. We have completed step 1 and step 2. Let's continue with step 3, power lever push-pull cable rigging. Set power lever at flight idle and insert the rig pin. Install the rig pin at quadrant. If the rig pin cannot be inserted easily, adjust the end fitting at quadrant as required. Let's observe how to do it. Put the condition lever at auto. Make sure you can insert the rig pin easily. This is good, right? Then put the power lever at flight idle. Same, make sure you can insert the rig pin easily. Good. Install the rig pin at the cockpit quadrant. The access is a bit difficult, but you can do it. If any of the rig pins, either at power lever or quadrant, cannot be inserted easily, perform the adjustment as follows. At cockpit quadrant, disconnect the push-pull cable at the end fitting. Now we are separating the quadrant from power lever, and you shall be able to install the rig pin at power lever easily. With the end fitting still disconnected, now install the rig pin at quadrant and adjust the end fitting either to extend or to shorten it to align the hole for bolt installation. Once the job is done, don't forget the basic practice to check the inspection hole to ensure that sufficient threads are engaged in. We have completed step 3, now moving to step 4, nacelle teleflex cable rigging. Nacelle push-pull cable or teleflex cable connects between engine side and airframe side. So now let's see how do we connect the tools together with the teleflex cable. For clarity, we have removed the teleflex cable and put it into the board for our review. Let's see it together. We have teleflex cable connecting airframe side at nacelle quadrant with engine side at MFCU upper lever. There is aft support on nacelle side and forward support on engine side. Let's observe how it moves. I am putting a white mark here to appreciate which one is moving and which one is not. Moving from ground idle, flight idle, takeoff notch, maximum takeoff, back to ground idle, max reverse, ground idle. Put power lever at flight idle. Install the rig pin at nacelle quadrant. Install the rig pin at MFCU upper lever. If adjustment required, meaning you cannot install the teleflex end fitting into MFCU upper lever easily, adjust the forward support as follows. Teleflex cable check. Check the inspection hole. Make sure it does not go through. Check the drain hole. Location is at the bottom. For power lever travel check, for MFCU side, put power lever at maximum takeoff at the most forward stop, and the gap should be 0.2 inch minimum. For nacelle side, put power lever at max reverse at aft stop, and the gap should be 0.2 inch minimum. Check also the thread length is equal at forward and aft support. We have learned teleflex cable rigging, so now let's apply it at the real case. Power lever unable to reach forward stop. Take a look at engine number 1 power lever. It is not able to reach maximum forward stop, also known as ram or wall. Now you can see at forward support near MFCU that the teleflex cable has reached mechanical stop with no gap. So what happens with this engine? The power lever movement is limited as the teleflex cable is limiting it and has reached the stop. The rectification was forward and aft support adjusted. We also found the teleflex cable IN fitting at the nacelle quadrant was too short. Readjustment was carried out. Why can't we adjust in service teleflex cable by extending or shortening the end fitting? The end fitting is adjusted one time only for new teleflex cable installation. Of course, if it has been disturbed, we may need to readjust it. In service teleflex adjustment is done by positioning forward and or aft supports as we have learned. Adjusting the end fitting more than required will change the teleflex maximum and minimum stroke, and it may result in power lever limited travel as we have learned. Alright, we have completed power lever control rigging. Now let's continue with power lever travel check. Set power lever in maximum power. Install rig pin at MFCU upper lever as shown. This is not at flight idle position. Perform slack check by moving the power lever. The limit it is 2 degrees plus minus 1 degree. With rig pin removed, move power lever from max reverse, this is aft stop, to maximum forward stop, also known as wall or ram. Make sure the power lever movement it is not restricted. Closing up, we have learned MFCU and PVM rigging, cable tension check, cockpit push-pull cable rigging, and also nacelle push-pull cable, also known as a teleflex cable rigging. That concludes other adjustment of the power control. Next step, we will learn how to rig propeller transfer tube. Propeller oil transfer tube adjustment. Although it is not part of the other adjustment of power control, we would need propeller transfer tube adjustment for torque split troubleshooting to be discussed at part 2 later on. So let's see how we do it. Move the propeller blades into full feather position. Full feather. Remove the locking cap assembly. With the cotter pin and headed pin already removed, loosen and remove the adjustment nut. Push the oil transfer tube firmly by hand until it touches the hard stop on the PVM. Then install the adjusting nut Turn it by hand until it touches the yoke shaft shoulder. Use a marker to mark the position of the transfer tube adjusting nut. Turn the adjusting nut clockwise 4 complete turns and then align it at the nearest locking hole. You can turn the adjusting nut to the nearest locking hole, then install the headed pin. Install the quarter pin through the headed pin. Do not bend the quarter pin more than 90 degrees. Push the cap assembly spring to the bottom. Turn it clockwise to engage the retaining nut slot. For checking, turn the cap assembly into opposite direction and make sure it stays. Closing up for part 1 after adjustment of power control and propeller transfer tube adjustment. The next step, we will apply the knowledge that we have learned to troubleshoot torque split issue at part 2. So let's continue to part 2. After completion of part 1, we are now at part 2, torque split troubleshooting. In this section, we will show you how torque splits happens and how to troubleshoot it. Let's start by understanding how the pilot typically operates the engine. At takeoff phase, both power levers at takeoff notch and power management set at takeoff. Both engines produce 90% torque. No split on power lever, no split on torque. Climb phase. After airborne, pilot will select power management to climb. Both power levers remain at takeoff notch, and both engine torque will modulate or vary depending on EEC calculation. No split on torque, no split on power lever. You are on cruise. Pilot will select power management to cruise. Both power levers still remain at takeoff notch. Cruise power setting it is set, and both engines produce equal torque. You can notice that both power levers have not moved from takeoff notch ever since takeoff phase. On descent, pilot will move both power levers away from takeoff notch in retarding direction. If one or both the engines are not correctly rigged, the torque may not be equal. This is the area where torque split usually happens at descent phase. As per FCOM, the limit of torque split out of notch operation is maximum 8% at steady state. Once the torque splits, pilot will adjust the power levers to make both torque equal. After power levers adjustment, the power levers will stagger. So what was started as a torque split will become power levers staggered after pilot adjustment. So now we know how the torque split or power lever staggers happen. The next step will be how to troubleshoot it. There are 3 main steps to troubleshoot torque split. Step 1, power lever cable slack check. Step 2, PVM and MFCU rigging. Step 3, propeller transfer tube rigging. In between those 3 steps, we may need to perform operational check by performing torque matching engine run. Of course, we don't need to complete all the 3 steps if the issue is already resolved at the current step. Also, since there is no method to find out which one is normal engine when power lever split, likely we would need to perform the task on both engines. For performing step 1, we will need to take the digital reading of power lever angle located at RVDT at MFCU by alpha collab. PLA alpha collab for ATR Dexis 100, the keyword is PLA, Papa 5 alpha, and the reading shown would be in degrees. No conversion required. For ATR Des 500, the keyword is PLA L and PLA R. Conversion will be required as shown. Refer to ATR service letter for more details. Step 1. Power lever cable slack check. Move both power levers in advancing direction Ground idle, take the reading. Flight idle, take the reading. At takeoff notch, take the reading. Do the same in retarding direction. At takeoff notch, take the reading. At flight idle, take the reading. At ground idle, take the reading. For engine number 1, when power lever at flight idle, you can see the delta is more than 2 degrees. It means there is likely a power control cable slack. So, if any of the engines has a delta PLA more than 2 degrees, perform other power control adjustment which we have learned at part 1. If the delta is less than 2 degrees, continue to step 2. For our learning purpose, let's continue to step 2. Step 2, MFCU and PVM rigging check. We need to do this task on both engines. Put power lever at flight idle, install the rig pin. Condition lever at auto, install the rig pin. Install the rig pin at nacelle quadrant. Once the rig pin is installed, let's check MFCU and PVM rigging. Put the rig pin at MFCU upper lever, as shown. Install the rig pin at PVM forward lever, as shown. Install the rig pin at MFCU lower lever, as shown. And rig pin at PVM aft lever. If any of MFCU or PVM rig pins are not aligned, we need to rig them. Disconnect the tail flex cable at MFCU upper lever. Adjust power lever and condition lever push-pull rods as required. Connect the tail flex cable to MFCU upper lever. If adjustment is required, adjust the tail flex cable at forward support. If there is MFCU or PVM from any engines required adjustment, let's confirm by performing engine run torque matching to see if the torque split is already resolved. If there is no adjustment at all, proceed to step 3, propeller transfer tube adjustment. Step 3, propeller transfer tube rigging check. Well, unlike others where we have rig pin and rigging holes, we do not have the same features for propeller transfer tube. So if we want to check the rigging, we have to redo propeller transfer tube adjustment as shown at part 1. Perform this task at one engine at a time and confirm if the issue is already resolved by performing torque matching engine run. With this, we have completed the 3 steps of torque split troubleshooting. Next, we will cover briefly on EEC and PEC trimming and engine run for torque matching. EEC and PEC trimming. Always perform EEC and or PEC trimming whenever any of the followings occur. Cable adjustment already carried out. MFCU and or PVM adjustment already carried out. Propeller transfer tube adjustment already carried out. Refer to related AMM topics for more details. Engine run-up torque matching. We perform engine run-up for torque matching to confirm if the torque split issue has been resolved. First, set power management selector switch to the cruise position. Put condition lever in auto. Move both power levers from ground idle position to achieve 82% NP. Then continue to move both power lever by 5 degrees step up to the takeoff notch. The torque difference between the 2 engines at every step should be less than 4%. With condition lever in auto, set power management to cruise. Increase both power levers until you attain NP 82% for both engines. Advance power lever to takeoff notch. Every 5 degrees, compare the torque. The delta should not be more than 4%. Once you are at the takeoff notch, retard power lever every 5 degrees increment. The torque between the two engines should not deviate more than 4%. If we have done the adjustment of power control and propeller transfer tube on both engines, and if delta torque is slightly more than 4%, there is a possibility to perform a fine-tuning. Perform this procedure on one engine only. Turn the adjusting nut clockwise, it will increase the torque. Turn it counterclockwise, it will decrease the torque. When there is a torque split or power lever staggered, how do we know which one is a normal engine? Meaning to say, which engine I need to rig first, engine number 1 or engine number 2? Well, currently we do not have the method to establish which one is the normal engine. It is recommended to check the rigging on both engines. Finally, we have come to the end. Just to recap, we have covered part 1, MFCU and PVM rigging, cable tension rigging, cockpit quadrant and the push-pull cable rigging, nacelle quadrant and the teleflex cable rigging. We then continue to part 2, applying what we have learned to solve torque split issue.
Hello everyone, we hope this video will provide you a better understanding how to rig engine and propeller.
And to troubleshoot torque split issue.
Goodbye.
Bye.